Periodicity in properties. This is a topic for the preparation of JAM examination. The contents I am going to discuss in this video is effective nuclear charge, atomic size and atomic radii, ionization energy, electronegativity, electron affinity, melting point and boiling point, electropositivity, diagonal relationship, acid-base character of oxides, summary of periodic trends. Then, effective nuclear charge. What is effective nuclear charge? Electrons in multi-electron atoms do not experience the full nuclear charge. Effective nuclear charge is the attractive positive charge of the nuclear protons acting on valence electrons. Effective nuclear charge is less than the total number of protons due to the shielding effect of core electrons. Calculation of effective nuclear charge is equal to Z minus S, where Z is the atomic number and S is the number of shielding electrons. Trends in effective nuclear charge increases across a period due to increasing nuclear charge with no increase in shielding effect. Decreases down a group, increased shielding counters nuclear charge. Therefore, it decreases down a group in the periodic table. Atomic size and atomic radii. This is the distance between the center of the nucleus and the outermost shell. Trend across the period and groups is it decreases across a period, increases down a group. Types of atomic radii. There are so many types of atomic radii, that is covalent radius, ionic radius, metallic radius, van der Waals radius. Covalent and ionic radius. The covalent radius is defined as half the distance between two covalently bonded identical atoms, which is determined by measuring bond length. Ionic radius is nothing but radius of an atom forming an ionic bond, range between 30 to 200 picometer, which is influenced by spin state, coordination number, etc. Then a small topic, that is isoelectronic ions. Isoelectronic ions, ions which have the same number of electrons. For example, aluminium 3 plus, Mg2 plus, sodium plus, all have the same electronic configuration, that is 1s to 2p6. These are all called as isoelectronic ions. Ionization energy. Ionization energy is the minimum energy required to remove an electron from the gaseous atom or ion, also known as ionization potential. It indicates the reactivity and bond strength. Factors governing ionization energy are positively charged nucleus, distance of the electron from the nucleus, number of electrons between the outer electron and the nucleus, repulsion between paired electrons. These are all the factors governing the ionization energy. Trends across the periodic table, it increases across a period, decreases down a group. Electronegativity. The concept of electronegativity is the tendency of an atom to attract shared electrons in a molecule. The concept of electronegativity is the tendency of an atom to attract shared pair of electrons in a molecule, which is affected by atomic number and distance of valence electrons from the nucleus. Factors affecting electronegativity are the size of the atom. Greater the size means lower electronegativity. Then nuclear charge. Greater charge means higher electronegativity. Effect of substituents. Nature of attached atoms affects electronegativity. Periodic trends of electronegativity across the period and group is it increases across a period, decreases down a group. Electron affinity. Electron affinity is defined as energy released when an electron is added to a neutral atom to form an anion. It reflects change in potential energy. What are the factors influencing electron affinity is atomic size. Smaller size means higher electron affinity. Nuclear charge, greater charge means higher electron affinity. Periodic trend of this is it increases across a period, decreases down a group. Melting and boiling points. Temperature at which a solid becomes a liquid at normal atmospheric pressure is known as melting point. Higher bond strength implies higher melting point. Boiling point is defined as the temperature at which vapor pressure equals surrounding pressures. A higher bond strength implies higher boiling point. Trends across the period and group in the melting and boiling points are decreases down the group and increases across a period. Electropositivity. Electropositivity is defined as tendency of an atom to donate electrons to form cations. Opposite of electronegativity, influenced by metallic character. They are. And the top electropositive elements are cesium, then rubidium, then potassium, francium, and then sodium. Diagonal relationship. Diagonal relationship is the metals are diagonally related in its properties. For example, the lithium and magnesium. Lithium is an alkali metal, magnesium is alkali earth metals. Lithium has the properties which are similar to magnesium than the same group metals. Acid-base character of oxides. They are the character across the periods and groups across a period from basic to acidic, down a group from acidic to basic. Stability of oxides decreases across a period. Basicity order is lithium oxide is less stable than sodium oxide, which is less stable than potassium oxide, which is less stable than rubidium oxide, which is less stable than cesium oxide. Amphoteric oxides are hydrogen oxide, beryllium, aluminum, and gallium oxides are amphoteric oxides. In the summary of the periodic trends, electronegativity increases across the period and decreases down the group. Ionization energy increases across the period and decreases down the group. Atomic radius decreases across the period and decreases down the group. Nuclear character increases across the period and decreases down the group. That's all about this lecture. Thank you.